So, hello everyone. This is lecture 8 on discrete mathematics. And in the previous lecture, I have given you a small homework. So, let me discuss that and then we will start our today's class. So, here was the problem. So, we have 11 persons. From 11 persons, we want to select 5 persons. And from 11 persons, we have 5 boys and 6 girls. Okay. So, and from the 5 persons, we will select 3 boys and 2 girls. Okay. So constraint is boy A is always included. So when we say boy A is always included, so what should be the answer? So obviously one boy is gone now. So we have to select 2 boys. Okay. So from how many boys we want to select? Okay. So that will
I
be
have
from the
answered this question, sir.
yeah. Come again.
I have answered this question, sir.
Okay, you have answered. Okay. So what is your answer?
4C2 into 6C2.
Yes. Very good. Okay. So I think it's clear. Second question answer.
Yes, sir. 4C2 into 5C1.
Yes. Good. Okay. Third question.
4C into 6C2.
Yes, very good. 4C3 into 6C2. Next.
Fourth question I have skipped, sir. Fifth question I have answered. I have not copied that question only.
Okay, okay, no
And
problem. Fourth question will be boy A.
I can answer.
Fourth. Okay, so yeah, you want some time. Okay, so I will answer it in the next.
Yes, sir.
Hmm.
Fifth answer I have written, but I am doubtful in this.
Okay, no problem. But
5C3 into 6C2
hmm,
into
hmm.
we have to specify the arrangement also. That is into 3 factorial into 2 factorial.
How you have got it? 5C3. So boy A and girl B should never be present together now. So see, we have to make cases here. Okay, so we will
Okay, sir.
make
I can
cases.
understand that. Okay, sir.
So what will be the cases A and B? So they should be never be together. So what are the possibility? Boy A is present, girl B is not present. Boy A is absent, but girl B is present, or both are absent. So 3 cases we have to take. Okay, so now you can answer it yourself. And
Okay.
another better way should be by complementary method. So we will pick entire thing. Okay, so what is the possibility? 5C3 into 6C2. That is the universal set. Okay, so from five boys you will pick 3 boys, or from 6 girls you will pick 2 girls. So from that I will subtract when both are present. So when both are present, so what is the possibility when both are present? So we will take 4C2 multiplied by 5C1. I think you have got it.
Yes, sir.
So this is my final answer for question number 5. Okay, so question number 4, I think it's very easy. You can do it yourself. So yeah, so take snapshot. I will jump to the next slide now.
Yes, sir.
Done?
Yes, sir.
Okay. Yes. So next is, so we have 1 to 10. Okay, numbers we have. So we have to select 3 distinct numbers and arrange them in ascending order. So many students get confused in this type of question. So what should be our answer? So many will say 10p3, but no, it is not the answer. See, I have told you directly we will not apply permutation. Okay, first we will choose and then we will arrange them. So select 3 distinct number. So from 10 numbers we want to select 3. So 10c3. Now we want to arrange them in ascending order. How many ways? Only one way is there. Obviously there is only one way to arrange them. Okay, so for example you pick 2, 3 and 1. So what is the way? 1, 2 and 3. That's it. So only one way. So answer is 10c3 only. Okay, so many of you will say because of the word arrangement, so we have to do permutation and all. No, I have told you clearly that we will not do these kinds of things. Okay, don't by heart anything, simply do it by your common sense, but the way which I have told you. So 10c3 into 1 is my answer. Please take snapshot. I will jump to the next slide.
Done, sir.
Next is combination with unlimited repetition. So the formula for combination with unlimited repetition is n minus 1 plus RCR. Okay, so now what is n, what is R? So don't worry, we will dig deep into all these things. Okay, but let me tell you one thing. We will study 5 problems. We will study. We will study 5 problems, and they are different problems, but actually they all will be same. Okay, and for all these problems we will use the same formula. What is the formula? N minus 1 plus RCR. Don't worry about proof and all. I will give you proof each and everything, but we will do all these things step by step. Okay, so for combination with unlimited repetition, we are jumping to the next category now. Combination with no repetition is over. So this is your category number 2. Okay, next category for the combination, that is combination with unlimited repetition. And what is the formula? N minus 1 plus RCR. What is N, what is R? We will come back to it, and we will study 5 problems. All of them will be, you will think that all are different, but actually they are all same, and all of them will use the formula N minus 1 plus RCR. What is the proof of the formula and all? We will study them after few slides. Okay, so let me jump to the next slide now. Please take snapshot.
Yes.
Okay, next, so first problems, we will study 5 problems now. So the very first problem is chocolate problem, and chocolate problem is your trademark problem. Okay, trademark problem. Like we have studied Mississippi problem. Mississippi problem. Okay, Mississippi problem was trademark for permutation with limited repetition. Okay, so same here for combination with unlimited repetition. Combination with unlimited repetition, we will use chocolate problem. That is your trademark problem. So I will not say combination with unlimited repetition and all. I will simply say it's a chocolate problem. So whenever we will see a kind of problem, I will say it is a chocolate problem. Okay, so we will remember it like that. Okay, so what is the you can say, what is this problem, chocolate problem? What it is saying, see, we have 3 kinds of chocolates: red chocolates, blue chocolates, and green chocolates. Okay, and they are available in abundance. That means unlimited quantity is available to us. Okay, and we want to select 10 chocolates. So how many ways? So obviously na, we have taken 3 chocolates, we can take 4 types of chocolates, 5 types of chocolates, and so on. So, okay, so I am just giving you a small hint how this problem look like. So we are considering a simple scenario where we have 3 different kinds of chocolates: red, blue, and green, and we want to select 10 chocolates. So what are the ways? Okay, so let me tell you this thing. So what are the ways? So directly, indirectly, I will say uh, we have taken, say, x numbers of red chocolates, and y numbers of blue chocolates, and z numbers of green chocolates. Okay, and that should be equal to what we want. This should be equal to 10. Okay, and what are the constraints? So I have written an equation: x plus y plus z is equal to 10. What is the constraint? Constraint is very simple: x, y, z should be greater than equal to 0. Obviously you cannot pick negative chocolates. So this is equation. So this entire problem boils down to this problem. We have x plus y plus z is equal to 10. This is the equation, and constraint is this. And now I want to find how many solution to this equation. Are you getting it? So now finally we want to find how many solution to this equation. How many solutions to this equation? Okay, that is the problem. So chocolate problem finally boils down to this problem. So we have an equation, and for this equation constraint is this, and we want to find how many solutions to this equation. So many of you will say, sir, we will have infinite solution because there are 3 unknowns and only 1 equation. So when we have say 3 unknowns and 3 equations, then we will have unique solution. But we have only 1 equation and 3 unknowns, so obviously it will have infinite solution. But no, it will have infinite solution when it can take negative values also. X, y, z can take negative values also. Only then we can have infinite solution. But here we will have only finite solution. So how many solutions are this? So that will be the answer to this chocolate problem. Okay, so let me tell you example. Let me show you some example. Okay, so for example, you can take 10 red chocolates, 0 this, 0 this. So finally you will get answer as 10. Okay, and if you take 0, 9, 1, obviously you will get 10. Okay, so you can take 0, 10, 0, that will give you 10. Okay, so many solutions are there like that, many solutions. So 1, 2, 7 also 10. Okay, 2, 3, 5 also 10, dot 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 dot. So now I want to find how many solutions are these. So for that we have a formula. What is the formula? N minus 1 plus RCR. Okay, n minus 1 plus RCR. So what is n? N is the number of variables in the equation. Number of variables. What is R? R is the RHS of the equation. So now I think you have got it. How many variables we have? 3 variables. So 3 minus 1 plus 10C10. This is my answer. So this comes out to be what? 12C10. So 12C10 is nothing but 12C2. So 12 into 11 divided by 2. So it comes out to be 66. So I will say total 66 ways are there. So to select 10 chocolates from these, so how many ways are there? 66 ways are there. This is the way to solve. Okay. So now you can take snapshot. I will jump to the next slide and I will show you many other questions. Don't worry, we will study lots and lots of questions regarding this topic. Okay.
Perfect, sir. Yes, sir.
Okay. So next, so we have to remember this fact. So in NCR, N should be greater than equal to R. Okay. R is greater than N, that is never possible. So for example, I say 10C2, that is T, okay, 10C3, okay, 10C10 also okay, but 10C11 is not okay. That is 0. So from 10 objects, how you can pick 11 and all? That is not at all possible. Okay, but in case of n minus 1 plus RCR, so n can be greater than R, that is possible, n is less than R, that is possible, and n is equal to R, that is also possible. So everything is possible. Okay, so for example, if n is greater than R, how it is possible? So numbers are more than RHS. So I can take like this. So we have say we want to select 3 chocolates. Okay, and sorry, we want to select 2 chocolates. Okay, and we have 3 different kinds of chocolates. So obviously n is what? N is 3, number of variables are 3, RHS is 2. So obviously it is possible. Who is stopping you for doing all these things? Okay, are you getting it now? So we have say we have abundance quantities of red chocolates, we have abundance quantity of blue chocolates, okay, and we have abundance quantity of green chocolates, and we just want to pick 2 chocolates. So how many ways? Obviously that is possible. Now who is stopping you from doing these things? So what? So how we will apply the formula? X plus y plus z, that is equal to 2. So n is what? 3. N minus 1 plus r is 2. C r is 2. So what will be our answer? 3 plus 2, 5 minus 1, 4. 4C2. 4C2 is the answer. That is nothing but 6. 6 is the answer. If you are not able to follow how 6, so I think 4 into 3 divided by 2. So 6 is the answer. Only 6 ways are there. No, possible. The main thing is possible. N is less than R. Obviously possible. I have just shown you. X plus Y plus Z, that is equal to 10. I have shown you. Okay. RHS is more than number of variables. And they are equal. That is obviously possible. Who is stopping you from doing these things? X plus Y is equal to X plus Y plus Z is equal to 3. Okay. So we have taken 3 chocolates. X plus Y plus Z, that is equal to 3. That is also possible. Okay. So nobody is stopping us from doing these things. Okay, so in fact you can take like this also. So x1 plus x2 plus x3 plus x4, that is equal to 4. Okay, so for example we have 4 different kinds of chocolates and we want to pick 4 chocolates only. So how many ways? That is a problem. So I think it will create no problem to us and it is possible. So the basic scenario is this has been asked in GATE. Okay, so NCR, so n should be greater than equal to r, but r greater than n, that is never possible. But n minus 1 plus RCR, n is greater than r is possible, n is less than r is possible, n is equal to r is possible. That is no relation between n and r. I hope I have made the point clear. Please take snapshot. I will jump to the next slide now.
Done, sir.
Okay. Yes, so the next is, so we have say 1 rupee note, 5 rupee note and 10 rupees note, and they are infinitely available to us and we want to select 10 notes. How many ways are there? Okay, so so how many ways are there? So let me tell you. So same thing, na? So I think you have got it. Red chocolate, green chocolate, blue chocolate and so on. So I will say like this: x1 plus x5 plus x10, that is equal to 10. Okay, so x1 is the number of 1 rupee note, number of 5 rupee note, number of 10 rupee note. Okay, so answer is 10. Okay, yes, so what will be our answer? So same scenario. Okay, so and we want to pick 10 notes. Please do not think like we want 10 rupees. I'm not saying we want 10 rupees. I'm saying 10 notes. So we can pick any number of notes like that. Okay, so we can pick here 0, 10, 0, 0, 0, 10, 10, 0, 0, 0, 1, 9 and so on. So how many solutions? Same. N minus 1 plus RCR. Okay, and constraint should be that. What should be the constraint? X1 x1 greater than equal to 0, x2 greater than equal to 0, sorry, x5 and x10 greater than equal to 0. Okay, so non-negative, we should say like this. So we should say like this, non-negative integral solution. Non-negative integral solution we want. Why we want integral solution? Because point values are not allowed. Now we cannot pick 9.5, we cannot pick 0.5 and so on. Okay, so I think you have got it. So we should say technically non-negative integral solution. Okay, so n minus 1 plus RCR, we will apply the formula and get the answer. What is n? Number of variables 3 minus 1 plus what are RHS? 10, C 10. So 12C 10, it is nothing but 12C2 and it is nothing but 66 is the answer. We have just solved it. Okay, so same answer. So now my question is, infinite quantity, is it necessary? No, it is not necessary. So if we have more than 10 nodes of each quantity, then it is not at all problem for us. Okay, because anyhow we cannot take more than 10 here or here or here. Okay, so at most we can take 10 now. So directly indirectly what should we say, that number of 1 rupee note should be 10, 5 10 and 10 rupee note also 10. So if we have 10 10 10 quantities of these, that is sufficient for me and I can apply this formula. Okay, so let me write it properly if you have any doubt. So it is not necessary that we should have infinite quantity.
Yes, sir, understood, sir.
Okay, then it's good. So if anybody is having any doubt, you can rewind the video and watch it again. Okay, so it is not necessary that we should have infinite quantities, so no problem. Okay, so please take snapshot. I will jump to the next slide.
Done, sir.
Next is go to a shop to buy 10. I have written in a shortcut manner. So we go to a shop and we want to buy 10 CDs, and 3 types of CDs are available. How many ways? So 3 types of CDs. So first type of CD, second type of CD, third type of CD. We want to select 10 CDs, and obviously in a shop abundant quantities of this will be available. If it is not available, then they will say first type of CD only 5 are available, second type of CD only 8 are available, and so on. That is completely different kind of problem. We will solve that also, don't worry. But here we will assume that abundance quantity is available. So same scenario. Okay, so we'll apply constant x1 should be greater than equal to 0, x2 should be greater than equal to 0, and x3 should be greater than equal to 0. So same, n minus 1 plus RCR. So what is n here? N is number of variables, that is 3. 3 minus 1 plus 10C 10. So 12C2. So let me write it properly. 12C10. And it is nothing but your 12C2, and that is nothing but 66 is the answer. Again, so I am just showing you the variety. Okay, what type of questions they can ask. Okay, please take snapshot. I will jump to the next slide.
Done, sir.
So now next category, non-negative integral solution. So so this is the second problem. I have told you na 5 problems we will study. First problem is chocolate problem. We have done it. So next is non-negative integral solution. So what is this? So this is equation is given to us, and they will say how many non-negative integral solution to the equation is possible. I think you have got it. Same scenario. So you can consider them as we have 4 different kinds of chocolates. Okay, so and we want to pick 10 chocolates. How many ways? Same scenario. Okay. Yes. So what will be our answer? So I will say n minus 1 plus RCR. Okay. So what is n here? 4 minus 1 plus R is what? 10. C 10. R means RHS. R means RHS. N is number of variables. So 13C10. So that is nothing but 13C3. So 13 into 12 into 11 divided by 3 into 2 into 1. Okay. Yes. So 3 4s are 12. 2 2s are 4. So I think you can do it. 13 into 2 26. 26 into 11. So 11 6 the 66. And 22 286 is the answer. Okay. Yes, please take snapshot. I will jump to the next slide.
Done, sir.
Okay, so the next is identical ball in the box problem. Okay, that is third category of problem. Okay, so I think I should not give you some other questions. You have got it now. So we can take questions like a plus b plus c plus d is equal to 20. How many non-negative integral solution and all? You can do it in homework also. Okay, so these are very simple scenarios, and I have explained one problem, so I think you can solve any kind of such problems. Okay, Yes, so next is identical ball in the box problem. So it is a kind of distribution problem. What it is saying, so we have identical balls. Balls are identical. Please try to follow it. Balls are identical, okay, but boxes obviously box identical ball in the box problem. So boxes are different. Okay, obviously boxes are different. Boxes are not identical, but balls are identical. So we have few balls. Okay, all of them are identical, and we have few boxes. So we want to put the balls. Okay, so there is no restriction. One box can have how many balls and all. You can put all the balls in one box. You can put say two balls here, two balls here, three balls here, and so on. So how many ways of doing that? That is the question. Okay, so let me show you the I hope I have explained the point clearly. We have identical balls and we have boxes, so we want to put identical balls in the boxes. That is known as identical ball in the box problem. And why I'm calling it as a distribution problem, because I am distributing these balls among the boxes. Okay, I have balls and I am distributing them among the boxes. That's why I'm calling it as uh, distribution problem. Okay, and what kind of distribution problem it is. So don't worry, we will study distribution problem in detail, but I will tell you this thing: identical to distinct type of things. Okay, we have identical balls and we want to distribute them in distinct boxes. Okay, identical to distinct kind of problem it is. Okay, so let me show you example. 10 identical balls and 4 boxes. How many ways to distribute ball in the boxes? So what is the scenario? 10 identical balls are there and we have 4 boxes. So how many ways to distribute them? Distribute balls in the boxes. So I will say like this: box number 1, x1 balls are coming to the box number 1, x2 balls are coming to the box number 2, x3 balls are coming to the box number 3, x4 balls are coming to the box number 4, and sum of them should be equal to 10. And obviously what I will say, x1, x2, x3, x4, they should all be greater than equal to 0. So directly indirectly same scenario, non-negative integral solution. So what will be our answer? N minus 1 plus RCR. So n is what? 4 minus 1 plus 10C10, 13C10, that is nothing but 13C3. So we have calculated it. 286 is the answer, I think so. Yeah, 286 is the answer. I think you have got it. Okay, so same what x1 is telling. So this is the basic scenario. Okay, you should know this thing. What x1 is telling? X1 is telling number of balls in first box. X1 is telling number of balls in first box. Okay, and there is no constraint on it. So minimum number of ball can be 0 and maximum can be 10. So when there is no constraint, only then we can apply this formula. Okay, so rather I should say directly only one constraint is there. That means all should be greater than equal to 0. That is the constraint, and no other constraint like at least one ball should be there in the box. Such type of question have been asked in GATE, by the way. Okay, so how many ways to arrange 10 balls in 4 boxes such that every box should have at least one ball? Or and I think fish and pond problem we have seen. So 10 identical fishes are there and 3 ponds are there, and we want to distribute fishes in the pond such that every pond should have at least one fish. Don't worry, I will solve this type of question. These have been asked in GATE. So these are constraints. So whenever constraint is not there, then you will apply this formula. Okay, so x1, you should think about it. X1 can take value from 0 to 10. X2 can take value from 0 to 10. Like this, you have to first think, and then you will apply the formula. Same scenario here, 0 to 10. Here also 0 to 10. Okay, so once you write the equation, after writing equation, you should first of all think what are the values which it can take. So since I will say indirectly there is no constraint, I will apply the formula and get the answer. Okay, so no constraint, let me write it in the note. No constraint, then apply n minus 1 plus RCR. Otherwise you cannot apply it. Okay, yes. So as the name suggests, non-negative integral solution. Okay, so for that we have this formula. Okay, please take snapshot. I will jump to the next slide now.
Done, sir.
Okay, so now I will tell you the proof of n minus 1 plus RCR. Why I have got this formula. So from this problem only I will tell you 10 balls and 4 boxes. Okay, so I will say these are the 10 identical balls. 1 2 3 4 5 6 7 8 9 10. Yes, 10 balls I have done, and we want 4 boxes. So how I will imagine the boxes? I will say like this. This is the box number C. I will apply once. So like this I have applied. So indirectly I have got 4 boxes now. First box has 3 balls, second box has 3 balls, third box has 2 balls, fourth box has 2 balls. Are you getting it? So we have balls, you can imagine them as zeros. Okay, and boxes you can imagine them as ones. So 4 boxes were there, but I have applied only 3 ones. So when I apply 3 ones, I have got 4 boxes. Okay, yes. So what will be our answer? See, so directly indirectly this problem boils down to what? We have 10 zeros and 3 ones. How many ways? How many binary numbers are there? So that is nothing but your Mississippi problem. Okay, so permutation with limited repetition, Mississippi problem. So I will add them 10 zeros and 3 ones. So assuming all are different, so 13 factorial ways to arrange them, but 10 zeros are same, repeated, so that means divided by 10 factorial, and 3 ones are same, repeated, so 10 factorial upon 13 factorial upon 10 factorial, 3 factorial. So this is nothing but 13C3 only. Okay, and what n minus 1 plus RCR is giving us? What is n here? And so 4 boxes are there na? So I think I should write the equation x1 plus x2 plus x3 plus x4, that is equal to 10. So what is n here? Number of variable 4 minus 1 plus r is what? 10. Okay, C 10. So so it is giving us value 13C10, and that is nothing but 13C3. So this is the proof that why n minus 1 plus RCR is working. Okay, so from identical ball in the box problem, we have proved this formula, n minus 1 plus RCR. Same answer is giving us na 13C3 only. Okay, so I hope it's clear to everyone. Okay, and you can think like this also. So you can imagine, see, there are 13 places na, zeros and ones. How many zeros and ones are there? Total 13 zeros and ones are there. And from these 13, so and on these 13 you want to choose 10 places where these zeros will be placed, or you want to choose 3 places where 1 will be placed. So 13C10 or 13C3, same is the answer. Okay, we have got this. I think it's fine now. Yes, take snapshot. I will jump to the next slide now. So next is fourth problem is outcome of identical coin and dice. Okay, so please try to focus here. What we are saying is outcome of identical coin and dice. Okay, identical. All the coins or the dice are identical. So what is the first question? If 10 identical coins are tossed, how many outcomes are possible? So since by default we take all the coins to be different. So when we toss 10 coins, how many ways? So if they are distinct, if they all are distinct, so I think we will apply the box method. So first coin, 2 possibility, head or tail. Second, 2 possibility, 2 possibility, 2 possibility, and so on. So how many are there? 10 coins are there. So 2 power 10 is the answer if distinct word is given. But since it identical word is given, so you can imagine that all are now identical. They are not different. So directly indirectly, if I say here we have head, here we have tail, here we have head, here we have tail, and so on, this is type of problem. So identical means actually 10 will be a bit big number. So let me take 3 coins. Okay, 3 coins. So head, tail, head, and tail, head. All these 3 will be same. Why? Because the coins are identical. So I cannot say first coin has given head, second coin has given head, third coin has given tail, and so on. I cannot say like this because all are identical. So I will say, I will say 2 head and 1 tail. That's it. This is the way. So you can think 10 identical coins means you have just tossed 10 identical coins. So they are on the floor. 10 coins are on the floor, and now you are counting how many heads and how many tail. That is the question. It is the best way to visualize. So outcome of identical coin means identical coins have been tossed. So all of them are on the floor, and now you are counting how many heads and how many tails. That is the way. I think you have got it. Okay, yes. So now for identical, what should be done now? So I will say let x is the number of heads, and xh means number of head, and xt means number of tails, and that should be equal to 10. So you getting it now? Xh means number of heads. So number of heads can be what? Minimum 0 and maximum 10. Xt means number of tails. So minimum 0, maximum 10. So I think we have got the equation, non-negative integral solution of this. So I will simply apply the formula, n minus 1 plus rcr. What is n? 2 minus 1 plus r is what? 10. C 10. Okay, so it comes out to be 11c10, or it is nothing but 11c1, and that is nothing but 11.
Yes, sir.
Okay, and if we want to prove, then obviously we can prove it also. See this is very simple. I will manually count it. Okay, so what I will say, number of head and number of tail, 0 10. Okay, then one head, then obviously 9 tail. 2 8 3 7 4 6 5 5 6 4 7 3 8 2 9 1 10 0. Only 11 solutions. Okay, I think you have got it.
Yes, sir.
Okay, so this is the way. Okay, so this is outcome of identical coins. Next is identical dice. So please, you have to in gate exam you have to read the question very carefully. So if 10 coins are tossed, how many outcomes? Identical word is missing. I have told you many times in the previous classes also. Identical, if identical word is missing, you will consider them everything to be distinct. So answer will be 2 power 10. Simply 10 coins are tossed, how many outcomes? 2 power 10. But if they say 10 identical coins are tossed, then how many outcomes? Then you have to answer this thing. That means only 11 outcomes are there. Okay, so that's it. So let me jump to the next slide now. Please take snapshot.
Done, sir.
Okay. Next is 10 identical dice are thrown, how many outcomes? So this is important. 10 identical dice. So see, many of you, some of you in gate exam, they will calculate this manually and they will take the answer as 11. But this thing doing manually is almost next to impossible. 10 identical dice are thrown and how many outcomes are possible? So let me tell you this thing. So number of ones, x1 means number of ones, number of twos, number of threes, 4, 5 and 6. That should be equal to what? Number of, and that should be equal to 10. Why? Because 10 identical dice have been thrown. So x1 can take value from 0 to 10, x2 can take value from 0 to 10, and so on. So number of ones can be minimum 0 and maximum 10. Number of twos can be minimum 0, maximum 10, and so on. So let me tell you. Okay, I think many of you will get confused after few slides. So I'm writing it properly. What x1 means? X1 means
Done.
number of ones. Okay, number of ones on dice. On dices. Okay, different dices. So number of ones. What is this? Number of twos, number of threes, and so on. So this should be equal to 10. So now I think it's clear. And what is the constraint? Minimum 0 and maximum 10. They can take this. So I think there indirectly there is no constraint. Only one constraint, that is no negative integral solution. That's it. So n minus 1 plus rcr. What is n here? N is number of variable, that means 6, minus 1 plus r. R is 10. C 10. So 15c10. So that is nothing but 15c5. So 15c5 is a very big number. Manual calculation is almost next to impossible. Manually you cannot do it. 15c5 is my answer. Okay. Yes. So now please take snapshot. I will jump to the next slide now.
Done, sir.
Done. Okay. Okay, so and if they say 10 dice are thrown, how many outcomes? Let me show you that thing also. So that will be simply box method. So every dice 6 possibility. So 6 power 10. Okay, that is very simple. So if distinct, or let me write it like this: if identical word is missing, identical. If identical word is missing, if identical is missing, then this is our answer, 6 power 10. Okay, now I will jump to the next slide. Next is dice sum and digit sum. This is another problem. So I think you have got it now. So this was our fourth
Yes, sir.
problem. I have to study 5 problems. Four problems are over. Next is fifth problem. That is the last problem, dice sum and digit sum. So what is this? 3 dices are tossed. Sum of all dice should be 5. That is the question. So how many ways? So now I'm not saying identical dice. So obviously they are different. So I have just thrown 3 dice. Okay, and I want sum of all the dice should be 5. How many ways are there? That is the question. So let me handle it and let me show you how we can do it. Okay, so 3 dice are thrown. So x1 is the output of first dice, x2 is the output of second dice, x3 is the output of third dice. Okay, and what sum of output should be? 5. I think you have got it. So x1 is, see, this is the basic difference between previous problem and this problem. X1 is output of first dice, x2 is output of second dice, and so on. So now please tell me what are the possible values of x1. X1 minimum value is
1 to 6.
1. Yes, 1 to 6. Now please tell me, can I apply this formula? N minus 1 plus RCR? No. Why? See this, I have told you 0 to 10 like this. So there should be no constraint. So here I have a lower constraint, that minimum it should be 1. But if minimum was 0, only then I can solve, and I can apply this formula N minus 1 plus RCR. So here I cannot apply it. So what is the solution? So let me tell you that solution. Okay, I will come to solution of it after few slides. I can tell you no doubt here itself, but it will create some kind of confusion in your mind. Don't worry, I will come back to this slide after a few slides. Okay, so after few slides I will come back to here, but this is for sure that I cannot apply this formula for this situation. For present situation I cannot apply this formula. Okay, and why I cannot apply? Because constraint is the see, upper constraint is no problem. Maximum value can be 6 also, but 6 and here we have 5, so no problem at all. So you can think like this. So red chocolates, we have 6 red chocolates and we want to pick only 5 chocolates. So obviously how you can pick 6? That is not possible. So I can say x1 upper constraint is not there, but lower constraint is there. Are you getting it?
Yes, sir. Yes, sir.
Okay, so yeah, now take snapshot. I will jump to the next slide.
Done, sir.
Okay, so next question is, how many 3-digit numbers will have sum as 8? That is another question. Okay, so I have told you, no, what is this? Dice sum and digit sum. Dice sum is over. I have shown you one problem. 3 dices are tossed. Sum of all dice should be 5. So how many ways are there? So I have told you this is the way. Okay, and the next is digit sum. So digit sum is how many 3-digit numbers will have sum as 8. That is the question. So like this. So for example, I can have 1, 2, 4. No, 1, 2, 5. 125 is the number. So what is the sum of the digits? 8 is the digit. So 125 is such number. So now I want how many 3-digit numbers are there that have sum as 8. Yes, so how we can answer? So I will say x1 is the first digit, x2 is the second digit, x3 is the third digit. Sum of the digits should be equal to 8. Now can you tell me minimum value of x1 and maximum value of x1?
So 1
Minimum
to
is, yes, very good, 1 to 9. x2,
as 1 to 9 is already taken, 2 to 8.
no. Repetition is allowed in numbers.
Fine.
In
You
numbers,
can again
repetition
1
is
to
allowed.
9, 120, sir.
No, 0 to 9. x2 can take value 0 also, no?
Yes, sir. Yes, sir. Because the first digit.
Yes, x3 can take value from 0 to 9. Why here 1? Because 3-digit number was given. I cannot take 0 here. So here 1 to 9, here 0 to 9, here 0 to 9.
Yes, sir.
And I want sum to be 8. So I will say upper constraint is no problem at all, because we can take value 9 also. Okay, yeah, and repetition is allowed or not, you can check like this also. In chocolate problem you can link the problems. Linking will give you very beautiful ideas, so you can link it. So the very first problem, the trademark problem, is chocolate problem. So in chocolate problem I have said that we can take 0.55. Nobody stopping us to take. You can take 5 blue chocolates, 5 green chocolate, and you are taking 0 red chocolate. That is possible, no? And this has been counted here. N minus 1 plus RCR, that has counted this thing also. Repetition is allowed. Nobody is stopping us for not doing repetition and all. Okay. Yeah. So that's why I have said here repetition is allowed. So 0 to 9, 0 to 9. Okay. And here 1 to 8. So a simple example, 800. Sum of digit is 8. No problem. 0 is not allowed. So I will say 170. That is also okay. 1 3 8 na. So 8 2 and 4 and 2. Okay, and so on. I think you have got it. So 2 and 2 is repeated. No problem. It will not create any problem for us. Okay. So anyhow, we have counted it, and moreover, 224 and 242, they are different, and I have counted them twice. Okay, and 422, that is also different. So three ways. So I have counted these ways. So don't worry about it that I have not considered these things and all. I have considered all these things in the formula n minus 1 plus RCR. But anyhow, since we have this constraint, so directly I will say I cannot apply this formula directly. Of course, I can do some modifications and all. I will tell you those modifications in after a few slides only. But n minus 1 plus RCR cannot be applied. Why? Because x1 should take value from 0 to anything. Okay, so 0 to 9 is okay, but 1 to 9 is not okay for me. Yes, so I think it's okay. Please take snapshot. I will jump to the next slide now.
That's it.
Yeah, so now we are going to start the constraints, and after doing constraints we will solve the other questions. Okay, the things which we have done here. Okay, constraints are, so we will apply constraint on lower limit first. Okay, lower limit. So for example, I say 10 identical balls and 3 boxes, distribute them in such a way that no box is empty. How many ways? No box is empty means each and every box should have at least one ball. So what is the way? Very simplest way. I will say this is box number 1, box number 2, box number 3. So we have 10 balls. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And all these balls are, the basic thing is all these balls are identical. So whatever ball you want, you can pick. So for I will say, I will pick this ball and put it here. I will pick this ball, put it here. I will pick this ball, put it here. So now directly, indirectly, I have done this. Okay, so each and every box is having one ball. So how many balls are remaining? Only 7 balls are remaining. So now I will shift the problem. Okay, so what I will say? So I will say now number of balls in box 1, number of balls in box 2, number of balls in box 3. That should be equal to 7. So simple. I think you have got it. So now I will apply the formula n minus 1 plus RCR. Nobody stopping us. Why? Because number of balls in x1 first box can be 0 to 7. Okay, minimum 0, maximum 7. Everything is allowed now. Why it is allowed? Because one ball is here. Okay, so since I have given already one ball to it, so now I will say 0 is allowed. No problem, because when I will say x1 is having 0, so directly and indirectly one ball is there. So it will not create problem for us. So simplest way is what should be done now. So whenever we will say that no box should be empty, so you give one ball to each of the box, and then for the remaining balls you will apply the formula. So x1 plus x2 plus x3, that is equal to 7, n minus 1 plus RCR. So n is what? Number of variables are 3 minus 1 plus 7c 7. So it comes out to be 9c7, 9c7, and it is nothing but 9c2. This is my answer. I hope I have made the point clear to everybody. So next is, so see this is the basic rule. Add all lower limits and subtract it from RHS and apply this formula. That is the basic rule. Okay, so add all the lower limits. So no box should be empty, na? So directly and indirectly means what? So lower constraint was here also, and here also. So how 1 1 1, so 3. So I have added 3. 1 plus 1 plus 1, that is 3. So 10 minus 3, that is 7. So I have applied now formula. That is the basic thing. Add all lower limits and subtract it from RHS and apply this formula. Okay, so I hope I have made the point clear. And if you want me to write more formally, then I can write it like this also. So for this question, this question, our formula should be x1 plus x2 plus x3, that is equal to 10. But the constraint is x1 should be greater than equal to 1, x2 should be greater than equal to 1, x3 should be greater than equal to 1, because every box should have at least one ball. So now I will say, so this is creating problem for us. Lower limit, na? This is creating problem. This is also. So 1 plus 1 plus 1, that is 3. So I will add all the lower limits and subtract it from RHS, and then I will apply this formula. So adding means 1 plus 1 plus 1, that is 3. So 10 minus 3, that is 7. So directly indirectly now my equation will become x1 plus x2 plus x3, that is equal to 10 minus 3. And now I will apply the formula and get the answer. That is the basic way. Yes, now take snapshot. I will jump to the next slide.
Done, sir.
Okay, so yes, so this is a gate question. Very important question. Okay, so in gate exam na, you will find a very small twist. So it's my request to everybody, you should read the question at least 2 times and then answer it. So this is the question: a plus b plus c plus d is equal to 10. How many positive integral solution? Many of you will skip this word positive, and you will directly apply the formula 10 minus 1 plus n minus 1 plus RCR. Na? So if positive is not given, then what will be our answer? N 4 minus n minus 1 plus R 10 C 10. So 13 C 10, 13 C3. This is the answer. And by the way, in gate exam, A option will be this only, 13 C3. 13 C3 will be the A option. And many of you will take this option in excitement because we have done this question many times and all. But since they have not given how many non-negative integral solution, for non-negative integral solution, this is my answer, because non-negative means 0 is included, but now 0 is not included. Positive 0 is not positive number, so we have to apply this constraint also, positive. So what should be the answer now? I will say like this: a plus b plus c plus d is equal to 10, and our condition is that a should be greater than equal to 1, b should be greater than equal to 1, c should be greater than equal to 1, d should be greater than equal to 1. So what are the lower limits? 1 1 1 1 1 4. So for applying the formula, I will say a plus b plus c plus d, that is equal to 10 minus 4, that is 6. So now I will apply the formula: a plus b plus c plus d is equal to 6. Okay, so now n is what? 4 minus 1 plus r, RHS is 6, c 6. Okay, so it will be 9C6, that is nothing but 9C3. So 9C3 is the answer. B option is 9C3. This is correct. This is wrong. Okay, so you will find very minute twist in gate exam. But whatever you are studying, obviously whatever I am teaching on, whatever you are studying from any book, I can guarantee you that question will not come in gate exam. Okay, because professors are making the questions and they are teaching these subjects from 20-25 years, so they want variety, and no question is repeated in gate exam. Concepts are repeated, but questions are never repeated. So for and concept repetition means same concept, but question will be slightly twisted. They will make a different story for that question. Okay, so the better is try to grasp the concepts properly and try to read the question properly. That is the best way. Okay, because you will fall in trap in gate exam, and you will get lots and lots of negative marking just because you are not reading the question carefully. You will get negative marks. Okay, now let me jump to the next slide.
Yes, sir.
Yes, so next is see number of red chocolates, green chocolates, and yellow chocolates. Okay, and that should be 10. And this is the constraint which is given to us. So simple chocolate problem. Let me write it. This is simple your chocolate problem, but we have constraint. Chocolate problem with constraint. Okay, so what is the constraints? So see, number of red chocolate, number of green chocolate, number of yellow chocolate, that should be equal to 10. Okay, and red chocolate, green chocolate, yellow chocolate, all are available in abundance. But the thing is, minimum one red chocolate you have to take, minimum 2 green chocolates you have to take, minimum 4 yellow chocolates you have to take. So I think it's very easy. So now what we will say, XR plus X green plus X yellow, that is equal to 10 minus lower constraint, you just subtract it, 1 plus 2 plus 4, 4 plus 2 is 6, 7. So it comes out to be XR. I have told you the rules now, so I'm just applying that. That will give us 3. So now solve and get the answer. So what is the solution? N 3 minus 1 plus 3C3. So 5C3, 5C2, and that is nothing but 10 only. So 10 solutions are there. Okay. Yes. So now let me jump to the next slide. Please take snapshot.
Done, sir.
So next is a plus b plus c is equal to 10. So they have just given you an equation. Now this is not a chocolate problem. Okay, why? Because a is greater than equal to minus 2, I'm saying. So how number of chocolates can be negative? That is not allowed. Okay, so this is not a chocolate problem, that is simple mathematical problem, and that is the category 2, non-negative integral solution type of thing. So how many solution to this equation? They are saying a is greater than equal to minus 2, b is greater than equal to minus 1, c is greater than equal to 1. So let me solve it. So that is very simple scenario. So I will say a plus b plus c is equal to 10 minus. So first is minus 2, so apply minus 2. Next is minus 1, so apply minus 1. Next is 1, so you will apply plus 1. So I think it's simple. So a plus b plus c, that is equal to 10. So minus 2, na, this and this is gone. So it will be plus 2. So it will become 12. Okay. Yes, so answer will be n minus 1 plus RCR. N is what? Number of variable 3 minus 1 plus R. Right hand side is 12. C R, that means 12. So 15, sorry, 14C12. That is nothing but 14C2. 14C2 is the answer. So I think it's clear. Please let me know if anybody is having any doubt.
Clear, sir. Understand.
Okay. Let me jump to the next slide. Yes, so constraint on upper limit. So before that, the things which I have skipped, let me tell you this thing. So I think now it's very simple. 3 dice have been tossed. Sum of all dice should be 5. So how many ways are there? So x1 plus x2 plus x3, that is equal to 5. So x1 minimum value 1 and maximum 6. That is the thing. So 1. So I think now you have got it. So such that I will say like this: x1 plus x2 plus x3, that is equal to 5, such that x1 greater than equal to 1, x2 greater than equal to 1, and x3 greater than equal to 1. So now it's very simple. X1 plus x2 plus x3, that is equal to 5 minus 3. Let me write it properly. 5 minus 1 plus 1 plus 1. Okay. So x1 plus x2 plus x3, that is equal to 2. Solve and get the answer. So n minus 1 plus RCR. N is what? Number of variable. 3 minus 1 plus 2C2. Okay. So 4C2 is the answer. Very simple scenario. Now please try to listen here carefully. Please try to listen carefully. If they say, so I have not considered the upper constraint. X1 cannot have more than 6. But I have not considered 6 because sum is 5 now. That's why. And finally we are getting sum as 2. Forget about 5 also. I am getting 2. So now if I say sum of till 9, it is not the problem. Sum of dice is 5, no problem. 6, 7, 8, 9, up to 9, no problem. So let me write it like this: sum of all dice 9. That is very important point. Please try to focus. Sum of all dice 9. So I will say x1 plus x2 plus x3, that is equal to 9, such that I think you have got it. Everything should be greater than equal to 1. Or should I write it? I can copy it also. Yes, so I have copied it. Hmm. Yes. So now what I will say, x1 plus x2 plus x3, that is equal to 9 minus 1 plus 1 plus 1, because lower limit now, so I have applied it. So finally x1 plus x2 plus x3, that is equal to 6. So now x1 can take value from 0 to 6, no problem. X2 can take value from 0 to 6, x3 can take value from 0 to 6, no problem at all. So I will apply the formula and get the answer, n minus 1 plus rcr. What is n here? Number of variable 3 minus 1 plus what is r? 6. C 6. So it comes out to be 8c6, that is nothing but 8c2. 8c2 is my answer, no problem. But if they say sum of all dice is 10, that will be a very big problem for us. If I say sum of all dice 10, now it will be problem. I think from here I can copy and I will not waste time. I will simply say x1 plus x2 plus x3, that is equal to 7. Here I have applied 6, so here I will say obviously what we will get 7. Now it will create problem, because if I apply the formula n minus 1 plus rcr, so obviously we want this minimum maximum, it can take value 6. But if I apply the formula n minus 1 plus rcr, so I cannot apply it. Why? Because it will consider the case like this also. So how you will get 7 on the second dice, or how you will get the 7 on the first dice, and so on. So now I cannot apply this formula. Okay, so to solve such questions we have different rules. I will tell you these things after few slides. So you have to think about it, what they are presently asking. Okay, sum of all dice 10, that will create problem for us. Okay, so I hope I have made the point clear to everybody. Yes, and by the way, actually it will be a bit simple case. Why? Because only 3 possibilities are not allowed now. For n minus 1 plus rcr, only these 3 possibilities are not allowed. Rest all are allowed now. So you just subtract 3. I have counted manually. So you will just subtract 3 after applying the formula. So what will be the formula? N minus 1 plus rcr. So I think it should be 3 minus 1 plus 7c7. So it comes out to be 9c2. 9c2 minus 3 is my answer. Are you getting it now? Roughly I have told you. Okay, so 7, first place 7 is not allowed, second place or third place 7 is not allowed. Rest, no problem at all. Okay.
Yes, sir.
Yes. So we can do like this, but see, these are the way which I am doing. We should not do it in gate exam, because these are random things. And we do not know in gate exam our mind will be working or not, or how we will approach this type of question and all. So don't worry, I will tell you a perfect method to solve all such kind of question. Okay, so everything should be by proper method. Okay, because I have told you permutation combination is a system, it is not random thing. Okay, so it is just like popcorn thinking. Popcorn, I think you have seen now how popcorns are cooked. So one popcorn will go here, one popcorn will go here, one popcorn will go here, and so on. So like this, in our mind ideas keep on coming. Okay, so if you solve questions like this, it is not guaranteed that in gate exam you will be able to solve that question. Okay, so it's I think your luck at that particular moment, if your mind is working properly, or if you get click that method, you will be able to solve it. But if you are not able to, if in your mind it does not get clicked, then obviously you cannot solve it. So we should avoid such kind of problems. We should avoid such kind of popcorn thinking. Okay, so don't worry, I will tell you proper method. Okay, let me jump to the next slide now. Yes, so I think you have taken the snapshot.
Yes, sir.
Same scenario here. So how many 3-digit numbers will have sum as 8? So I have left it, so now I can solve it. So see this. So there is, by the way, there is no upper constraint, because they can take value up to 9 also, but here we want sum to be 8, no problem at all. And here only one constraint, that is minimum value is 1. No problem. I will subtract it. So finally what I will say, x1 plus x2 plus x3 that is equal to 8 minus 1 that is 7. Now I will apply the formula to get the answer. So what is n? 3 minus 1 plus 7c7. So it comes out to be 9c2 is my answer. Very simple. Okay. So now but if they ask how many 3-digit number will have sum to be 15, then it is out of scope for till now. For till the knowledge, the amount of knowledge which we are having, for till now it is impossible. What is the answer? So three-digit numbers, sum to be 15. Okay. So if sum to be 15, so I will say x1 plus x2 plus x3 that is equal to 15. So now minimum 1, maximum 9. Here minimum 0, maximum 9. So maximum 9 is possible. But if you simply apply n minus 1 plus RCR, so you will say sir 0, 15, 0. That is also allowed. But how x2 will take 15? That is not possible. So the knowledge, the amount of knowledge which we are having till now, it is not possible for us to solve this question. Okay, so because here we have upper constraint also. Upper constraint means 9. Maximum 9 is possible. Maximum 9 is possible. Okay, sum is 15. Okay, so I can say like this. So in chocolate problem we have unlimited chocolates. Now I will say we have only 9 chocolates, 9 red, 9 blue and 9 green chocolate, and I want to select 15 chocolates. How many ways? That is the type of problem. Okay, so limited we have not unlimited things. Okay. Yes, so that is nothing but, so I can say now properly, that is nothing but combination with limited repetition. So it is a completely next category of problem. Okay, it is completely next category of problem. Okay. Yes, so I think you have got it.
Yes.
Anyway, I will come back to it, no problem. I will tell you these things after a few slides only. Okay, I'm jumping now. Yes, so everything is over. So now I will apply upper constraint. So the condition is that constraint on upper limit. Okay, but condition is that only one variable. Only one variable, upper constraint is there. Upper constraint is there, and there should be no lower constraint. Lower constraint is not allowed. Okay, yes. So for example, I can say x1 plus x2 plus x3 is equal to 10. X1 should be less than equal to 8. So how many solutions are there? So the only way, see, everything can minimum 0, maximum 10, minimum 0, maximum 10, no problem. But x1 is minimum 0, maximum 8. That is the upper limit. Okay, so directly and directly 10, 0, 0 not allowed, 9, 0, 1 not allowed, and so on. So how I will apply that constraint? So I will say I will do it in a complementary manner. What I will say? Complement of it will be what? X greater than 8. Okay, x should be greater than 8. So if I say x should be greater than 8, and if I am able to solve that problem, then obviously from the total I will subtract it and I will get the answer. X should be greater than equal to 8 means what? X should be greater than equal to 9. Okay, greater than equal to is the main thing which we should concentrate. Greater than is not good. Greater than equal to constraint is good. So greater than equal to 9 we have to do. So no problem. So what I will say, x1 x1 should be greater than equal to 9. So I will say like this, x1 plus x2, we can easily solve it. That is equal to 10 such that x1 is greater than equal to 9. I have told you x1 greater than equal to 1 we have done many times. Greater than equal to 1, greater than equal to 2, greater than equal to 4. I have done many times these type of questions. So I can solve it very, very easily. So what a big deal here. So I will say, so this problem will be converted to x1 plus x2 plus x3 that is equal to 10 minus 9, that is nothing but 1. So I will apply the formula n minus 1 plus RCR. What is n here? 3 minus 1 plus R is what? 1, C1. So 1 and 1 got cancelled, 3C1, that is nothing but 3. So 3 ways for x1 is greater than equal to 9. And if I do not apply any constraint, so what will be my answer? So total is n is what? 3 minus 1 plus 10C10. 12C10 12C2. 12C2 is the total minus 3C1 I will do. So total minus complement. We will get the answer for one upper constraint, only one upper constraint. Okay, so I think you have got it. And manually also we can say na x is greater than equal to 9. So x1 should be greater than equal to 9. So only I have shown you only 3 solutions. So we can see it very easily. x1, x2, x3. Sum should be 10. So I can say 910, 901 and 1000. Only 3 solutions are there. No other way. That's why I have told you 3C1. Now, no doubt, manually we can do it, but I have told you, popcorn thinking we have to apply, we have to avoid in GATE exam. Manually also, by common sense, I can do this question and all, but I have not done it. I have shown you a proper system. What is the advantage of proper system? Now I can say x1 less than equal to 5 also, x1 less than equal to 4 also. So if I apply a very small number, then obviously that will create very big problem for us in GATE exam. Okay, that's why I have shown you proper method. Yes, please take snapshot. I will jump to the next slide.
Okay, sir.
Okay. Yes. So should I solve other questions, or I think it's fine now? Okay. So I think it's
You
fine.
can give me homework questions, sir.
Okay. Okay. I can give you homework question. So I can say like this. X1 plus x2 plus x3 that is equal to 10 such that x1 is less than equal to 3. Then x1 plus x2 plus x3 that is equal to say 15, x2 less than equal to 8. Okay, these two questions you can solve it very easily at your home. Okay. And I have said you constraint on upper limit, only one variable. Okay, if more than one variable, then it is out of scope for us. Okay, then we cannot solve it. I will tell you the proper method how we can do it. Okay, so if more than one variable constraint, then I cannot solve. Let me say it here. So if I say x1 plus x2 plus x3 that is equal to 10 such that x1 less than equal to 3, x2 less than equal to 5. I cannot solve this question. From the knowledge which I am having, I cannot solve this question because two upper constraint. Okay, and if we have upper constraint also as well as some lower constraint also, no, I cannot do it. Please do not think like that. Okay, if I say x1 plus x2 plus x3 that is equal to 10, x1 less than equal to 2, greater than equal to 2, and I am saying x2 less than equal to 5. No, I cannot do it because I have told you only one variable upper constraint is there and no lower constraint. Only then I can apply this method which I have told you. So these two questions, only upper constraint is there and no lower constraint, perfectly the method will be applied, but here it cannot be applied because two upper constraint I cannot solve it. One upper and one lower, I cannot solve it.
Do we have these things also, sir? We will learn this.
Yeah. We will do it. No problem. We will do it. So I will solve each and every constraint. I can apply lower constraint on all the variables, upper constraint on all the variables, and still I can solve it. I will tell you this thing by generating function. We will do it. Okay. So most probably in today's class only we will do it. No problem.
Okay.
Yes. So let me jump to the next slide now. So another type of question, very good question. X1 plus x2 plus x3 less than equal to 10. How many solutions? So so this type of question you can expect in GATE. So I have told you what. So they will be one step ahead of you. I have told you this. X1 plus x2 plus x3 is equal to 10. How many solutions? Direct formula we have told you. But they will ask this question. Less than equal to 10. How you will solve it? So I will simply say it. So I should solve this now. X1 plus x2 plus x3 is equal to 0. Then x1 plus x2 plus x3 is equal to 1. Okay, so let me copy it. then this, then I will say it should be equal to 2 equal to 3 and so on up to x1 plus x2 plus x3 is equal to 10, and I will add all the ways and then I will get the answer for less than equal to 10. Are you getting it now? Equal to
Yes, sir.
0, equal to 1, equal to 2 and so on. So obviously this way is not good. So we have to solve a lot of things. Okay, so what is the better way? Better way is I will apply, see the beauty of the mathematics, x1 plus x2 plus x3, I will apply another variable. I will apply a dummy variable x4 and then I will say it is equal to 10, and obviously x4 values can be from 0 to 10. So now if x4 is 0, then I will say x1 plus x2 plus x3 is equal to 10. When x4 is 1, I will say x1 plus x2 plus x3 is equal to 9. When x4 is say 9, I will say x1 plus x2 plus x3 is equal to 1. Are you getting it now?
No, sir.
No.
We
Okay, let me explain it. So see, every variable can take any value now. So I will say when x4 is 0, so you just forget about it. You will say x1 plus x2 plus x3 is equal to 10. This thing.
how
When
does
I
it
will
change?
say,
Mhm.
yeah,
Yes, sir. Yes, sir. Yes, sir. Got it, sir.
okay, and if I say x4 is say 9, so I will say you simply replace x4 by 9. So what I will get? X1 plus x2 plus x3, that is equal to 1.
Yes.
This thing.
Yes, sir. Yes, sir.
So all the 11 cases are covered by this only by adding only one variable, that is x4. Okay, and now see, there is no constraint at all. Every variable can take value from 0 to 10 only. So now I think everything is over. So I will simply apply the formula and get the answer. So for less than equal to, you just have to remember one thing. You just have to add one more variable and solve and get the answer. So what will be our answer? N. N is what? 4. 4 minus 1 plus R. C. R. R is what? 10. So 13C10, or you can say 13C3 is my answer. So simple. So for less than equal to thing, you just imagine one more variable and solve and get the answer. That's it. Okay.
Yes, sir.
Okay. Please take snapshot. I will jump to the next slide.
Done, sir.
Okay. Next is see this: 10 identical red balls, 15 identical yellow balls, 12 identical green balls. Distribute them in 3 boxes. How many ways are there? How you will solve such kind of question? So let me do it. So first I will say, see, I am having 10 identical red balls. Forget about them. You just simply say we have 10 identical red balls and you want to distribute them in 3 boxes. How many ways? I will simply say x1 plus x2 plus x3, that is equal to 10. No negative integral solution and we will get the answer. So 10 minus 1, sorry, n is what variable? 3 minus 1 plus r c r. Okay, so for 10 I have done it. So now 10 identical red balls, I have distributed them in 3 boxes. Now please tell me, my work is over or not? No, my work is not yet over. I have to then distribute 15 identical yellow balls. So for 15 I will simply say, so since our work is not yet over, so what is the sense? Multiplicative sense. So I will say 3 minus 1 plus 15 c 15. Then again I will say 3 minus 1 plus 12 c 12. I think you have got it.
Yes, sir.
Okay, so I think you can solve and get the answer. I should not waste time here. So what is the basic idea? So whenever we have 10 identical red balls, 15 identical yellow balls, 12 identical green balls, so for such kind of things, you first distribute first set of identical balls and then second set and then third set. That is very common sense. No? So first you will distribute 10 identical red balls and then you will distribute 15 and then you will distribute 12. That's it. Okay. Yeah. So it's just like that now. So there are 3 boxes and you tell your baby that 10 balls are there, so you just put them in the boxes. So he will put one by one and then you will say your work is not yet over, you have to distribute 15 other also, and then you have to distribute 12 other also. So obviously we can do it. Okay, yes, please take snapshot. I will jump to the next slide now.
Done, sir.
Okay, so next is, so 2 girls pick 10 lilies 10 lilies, 15 daffodils, and 12 sunflowers. How many ways they can distribute them? This is a gate question. So the only problem in this question was they have not given the word identical or distinct. So I have told you by default we have to take distinct. But here, if we take distinct, then we will not be able to find that answer in gate exam. Options were there. So according to options, we have to guess. Sometimes we have to guess according to options also. According to options. See, by default, I have told you, if I say 3 maths books are there, so you will say all the 3 maths books are different. They are not identical. I will say one is linear algebra, another is say calculus, another is say some other normal algebra and so on. Okay, so by default, we have to take everything to be distinct. So here 10 lilies are there, so I will consider them as distinct. 15 daffodils distinct, 12 sunflower distinct. I have to consider them as distinct only. But if I consider them as distinct, then answer was not matching in gate exam. So according to options, I have to check. So according to options, the sense was of identical. So that is another tip for you in gate exam. So whenever you will consider them by default as distinct only. But if options is not matching, then obviously you have to take them as identical. Okay, so now I think it's very easy. We have 2 girls, 10 lilies, 15 daffodils, and 12 sunflowers. So first you will distribute 10 lilies. So x1 is the amount of lilies for the first girl, x2 is the amount of lilies for the second girl, 10. So I think you have got it. 10 minus 2 minus 1 plus 10c, 10. Work is not yet over because then they will distribute daffodils. So 2 minus 1 plus 15c, 15. Work is not yet over, they will distribute 12. So 2 minus 1 plus 12c, 12. The way which I have solved this question, same way the question have been asked in gate. Okay, yes, so I think everybody can solve it. Should I solve it, or you will do it at your home?
We'll solve it, sir. We'll solve it.
Okay, so this is my final answer. So the tip is you have to see the options also. Okay, and by the way, if I consider them by default, if I consider them as distinct, so how many?
So your voice is lost.
Okay, voice has gone. Let me check it.
Okay, it's come, sir. It's come. It's come.
Okay. Yes, so I will say 10 lilies, 15 daffodils, and 12 sunflowers are there. So I will say, since all of them are different, so I will say 10 plus 15 plus 12. So 25, 37. So I will say 37 objects are with me. 37 objects are with me, and I want to distribute them in 2 girls because all are different. Okay, so by the way, it is a distribution problem, distinct to distinct. I will tell you after a few slides, distinct to distinct. I have to do it. Okay, don't worry. But I am just telling you, I am just giving you the hint that why this option was not making sense and all. Why distinct word is not making sense here. Let me show you. So 37 different objects are there, and you want to distribute them in 2 girls. So now what we will do, I will make a box. So I will say for the first object, what is the way? It can go to either first girl or second girl. So two options for the first object. Second object, 2 options. Third object, 2 options, and so on. So how many objects? 37. 2 power 37. That is very big number. 2 power 37 is very big number. So no option was matching like this. That's why I have told you that identical is making sense here. Distinct is not making sense. Okay, yes, so so 37 objects, 2 girls. Okay, so 2 power 37 is the answer. So some students get confused, sir, why not 37 power 2? Okay, so see, I cannot say na that a girl 1 will get at least one, you can say 1 flower or 2 flowers and all. So for I cannot say girl 1 which flowers it will get, I do not know. Girl 2 which flowers it will get, I do not know. But for the first flower, I can say only 2 choices, either go to girl 1 or girl 2. For second flower, only 2 choices, either go to girl 1 or girl 2, and so on. So each and every flower, only 2 choices, 37 flowers are there. So 2 into 2 into 2, 37 times, that is 2 power 37. Okay, yes, please take snapshot. I will jump to the next slide. Okay. So yeah, so now we are going to start combination with limited repetition. So now I will clear all the constraints and all. Okay, so that is combination with limited repetition. Next category, and it is done with the help of generating function. So please try to remember, my concern here is not to tell you what are generating functions and all. That is a separate topic. I will clear that after few lectures. Generating function is a separate topic and it is in GATE syllabus. So I will tell you these things and all after few lectures. So my concentration is just to solve this problem, combination of limited repetition, and I will take help of generating functions here. Let me tell you. So see, chocolate problem. So I will say 6 green chocolate, 3 blue chocolate, 8 red chocolates, and we want to choose 10 chocolates. How many ways? So this is the perfect example of combination with limited repetition. So I cannot repeat green chocolates unlimited times. Why? No, I cannot repeat it. Why? Because only 6 green chocolates are available. Only 3 blue are available. Only 8 reds are available. So and we want to choose 10 chocolates. So how many ways? So I will write it equation like this: x1 plus x2 plus x3. Rather, let me write it like this: x green, number of green chocolates; x blue, number of blue chocolates; xr, number of red chocolates. That should be equal to 10. But I have a constraint. What? X green should be less than equal to 6. X blue should be less than equal to 3. X red should be less than equal to 8. So three upper constraint I have given you. I have told you only one upper constraint I can solve. Okay, but three I have given. So now clearly this is combination with limited repetition, and I will solve this with the help of generating functions. Okay, now so lower constraint, there is no lower constraint. Okay, because minimum 0 we can select, no problem. I have not told you that at least one green chocolate should be selected, at least one blue chocolate should be selected, and so on. And I can apply that those constraints also, no problem at all. By generating function I can solve any constraint. Okay, so by GF, let me write it. By GF we can solve any constraint. We can solve any constraint. Okay, yes, take snapshot. I will jump to the next slide.
Okay, sir.
So now I can solve this also. X1 plus x2 plus x3 is equal to 12. Dice sum problem. So so minimum value will be 1, maximum will be 6. Minimum 1, maximum 6. Minimum 1, maximum 6. So I have applied constraint everywhere now. Okay, so I have lower constraint also, upper constraint also. So I can solve all these problems with the help of generating functions. Okay, so let me tell you these things, how I will approach this question. So because this is the most beautiful question which we can think, because every constraint I have applied, each and every constraint. So let me tell you how we will solve it. Yes, so step number 1 will be very simple. So I will clear all the lower constraint, and how to clear that we have told you many times. So step number 1 is clear all lower constraints. So now I think I can write it directly. X1 plus x2 plus x3, that is equal to 12 minus 1 minus 1 minus 1. It comes out to be 9. Okay, so now I have just upper constraint. X1 can be at most 6, x2 can be at most 6, x3 can be at most 6. Are you getting it now? So dice sum problem, I think you remember na, x1 plus x2 plus x3, that is equal to 12. So so first dice, output of the first dice, x1 is showing output of the first dice, x2 is showing output of the second dice, x3 is showing output of the third dice. So what are the output possible? 1 to 6, 1 to 6, 1 to 6. And but I want sum to be 12. So I have applied lower constraint also, upper constraint also. Lower because 1 1 1, minimum 1, and upper constraint because maximum 6 6 6. So step number 1 is clear all the lower constraint. I have cleared all the lower constraint, and finally x1 plus x2 plus x3, that is equal to 9, x1 less than equal to 6, x2 less than equal to 6, x3 less than equal to 6. So only 3 upper constraint are remaining, lower constraint are over. So clearing lower constraint is very easy. We will simply do it in the step number 1. Okay, now so now I will tell you step number 2. Okay, so I think you have copied this. So now let me show you step number 2. So step number 2 is I will write generating function for each and every variable. Write GF for each variable. So what is the generating function? So I will write it like this: a of x1. Generating function for x1, I will write it as ax1. ax1 means GF for x1. ax1. So how I will write it? I will write it like this: x power 0 plus x power 1 dot dot dot. What is the maximum value it can take? 6. So what I will say, x up. So see, I can go till 6 na. So I will write it here x power 5. Why? Because uh, from 0 to 5 counting is 6. Okay, that's why I will say like this. Are you getting it? Generating function for x1. Okay,
Yes, sir.
so
Understood, sir.
yeah, and um, okay, let me show you one more thing. Actually, see, I have done some kind of see, uh, when I have deleted the lower constraint I have deleted. So finally, x1 can go up to 5. It cannot go up to 6. Yeah, that is the mistake which I have done. See, I have deleted the lower constraint. So by deleting the lower constraint, it can take value up to 5. It cannot go up to 6. Why? Because I can say x minimum was this thing. Minimum was 1, maximum was 6. Outcome of first dice. So simply I have subtracted 1 from both the places. If I subtract here 1 and here 1, what I will get? 0 to 5. So that's why I should say like this. So x1 can be at most 5, x2 can be at most 5, x3 can be at most 5. Okay, so I think in the previous slides, wherever we have done the lower constraint kind of things, yeah, so lower and upper, by the way, there was no problem. Yes, there was no problem because there was no lower and upper constraint at the same place. But here we have lower as well as upper. So for that scenario, I have to subtract 1. Are you getting it?
Yes, sir.
So yeah, so the basic thing is, when I am subtracting 1 from here, so obviously upper value will also be gone. Okay, so I will say subtract 1 from both the sides. So finally, what I will get from it will take value from 0 to 5. It will also from 0 to 5. It will also take value from 0 to 5. So 0 is no problem because minimum constant we have deleted. So finally, we will get at most 5, at most 5, and at most 5. Yes, yeah. So for x1, yeah. So now it is clear now. So see, generative function for x1, x0 to x5 we have to take. Why 5? Because of this 5. Okay, so no problem, no doubt there are six variables are there, no problem. I will take like this only. Anyway, if you want, then I will give you proof also that why we are doing all this kinds of thing. But please, first of all, let me solve the question. Okay, yeah, so that was the small problem which we have tackled. Yes, so x1 can be at most 5, x2 can be at most 5, x3 can be at most 5. So generating function for x1 will be x0 plus x1 up to x5. Similarly, ax2, generating function for x2, x power 0, x power 1 up to x power 5. Similarly, generating function for x3, x power 0, x power 1, x power 5. So what is the answer? See this. This is a GP. X power 0 plus x power 1 plus x power 2 up to x power 5. So it comes out to be 1 minus x power 6 upon 1 minus x. Do you know the formula of GP? Yes. Okay, let me repeat it. No problem. See, if I am having say 1 plus say 1, if I write x power 0 plus x power 1, x power 2 dot 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 up to x power n. Okay, so this is GP now because common ratio is x. So every time I'm multiplying the term by x. So what is the sum of the sum of n terms of GP? That is a into 1 minus r power n upon 1 minus r. A is the first term. First term is x power 0. So that is nothing but 1 only. 1 minus common, r is the common ratio. Common ratio is x. And n is the number of terms. 0 to n terms are n plus 1 upon 1 minus r, that is 1 minus x. So 1 minus x power n plus 1 upon 1 minus x. So x power 0 to x power 5. Simply just count the terms. That's it. 1 minus x power 6 upon 1 minus x. And we can do it just because I am taking x to be less than 1. X is between 0 and 1. That's why I have applied this formula. This formula is valid when x is between 0 and 1. Okay. When x is between 0 and 1, this formula is valid. A into 1 minus r power n upon 1 minus r. Okay. And anyway, if x is greater than 1, then I will just take minus common, r power n minus 1 upon r minus 1. That is also no problem for us. Okay. So if x is greater than 1, or by the way, here also you can take minus 1 common. So r power n minus 1 upon r minus 1, we can do it. But I am just applying 1 minus r power n. Why? Because x is less than 1. So less than 1 means, say I can take 0.5. So 0.5 power 10, that is very small number. It is less than 1. So why? So that's why I will write 1 minus 0.5 power 10, so that I get positive value. If I write 0.5 power 10 minus 1, that we will get negative value, and it is not beautiful for us. Okay. So it's general suggestion, when x is from 0 to 1, we will apply this formula 1 minus r power n upon 1 minus r. But when x is greater than 1, I will apply formula r power n minus 1 upon r minus 1. Okay. I think you have got it. Now just take minus 1 common. Minus as common, you will get the answer. R power n minus 1 upon r minus 1. So our aim is to make the things positive. That's why we are doing like this. Okay. Yes, so finally 1 minus x power 6 upon 1 minus x. So here also 1 minus x power 6 upon 1 minus x. Here also 1 minus x power 6 upon 1 minus x. We have got it. Okay, now please take snapshot. Step 3 I will tell you in the next slide.
Okay,
Done?
sir. Yes, sir.
Okay. So next is step number 3. So step number 1 is clear all lower constraint. So by clearing lower constraint, upper constraint will also get affected. Why? Because minus 1 we have to do it. So finally we have got it. Okay, so now step number 2 is generating function for each variable we have to write. Next step is generating function for the problem. Generating function for the problem. So you simply multiply them. So generating function for the problem is represented by ax. That will be ax1 multiplied by ax2 multiplied by ax3. Okay, so it comes out to be 1 minus x power 6 cube divided by 1 minus x ka cube. I think you have got it. Now see this, I will simply multiply these three. Okay, yes, so we have got it. Yes, any doubt?
No, sir.
Okay, step number 4 is a formula. You have to by heart it. I will give you the proof in generating functions. So sigma r is equal to 0 to infinity n minus 1 plus rcr x power r, that is 1 upon 1 minus x power n. Sigma r is equal to 0 to infinity n minus 1 plus rcr x power r, that is 1 upon 1 minus x power n. Okay, yes, so now I will apply this formula here. So you can see 1 minus x power n is equal to this thing. So when if I take n is equal to 3, what will be the this formula become? So why I'm taking n to be 3? Because 1 minus x cube is I am having. So I will apply this. So what I will get? So take n is equal to 3. Take n is equal to 3. So what I will get? 1 minus x power 6 ka cube multiplied by r is equal to 0 to infinity, and n is 3 na. So I will say 3 minus 1 plus rcr x power r. Is it okay?
Yeah, sir.
Okay, yes, so now step number 4 is over. Now everything is perfectly fine. We can solve it very easily. So now from this equation we have to find coefficient of x power 9. Why we want to find coefficient of x power 9? 9 was the RHS. This 9 was our RHS na. So I will say find coefficient of x power 9. Step number 5. coefficient of x power 9. Don't worry, I will make you fluent in this, no problem. X cube multiplied by sigma r is equal to 0 to infinity r plus 2cr r plus 2cr x power r, and I want to find coefficient of x power 9. So this is a cubic equation, so I have to apply the formula and then I will get it. So what I will say, x cube, so first a minus b ka cube, a cube that means 1 plus b cube that means x power 18 minus 3ab, 3 into x power 6 into a minus b. So a is what, a is what, oh sorry, हाँ ठीक है 1 minus 3ab into a minus b, na, so a is this, b is this. Yes, this is the formula. Okay, yes, so we have got it. So now multiplied by sigma r is equal to 0 to infinity r plus 2cr x power r. Now I will show you like this. See, we want what, coefficient of x power 9. See this, coefficient of x power 9. So for, if I take this one and I will multiply this, so r should be 9, na? Are you getting it? That's why we will get x power 9, na? 1 into x power 9, that will be x power 9. So r should be 9. So put here r to be 9, 9 plus 2, that is 11, 11c9, or you can say 11c2. So let me write it. X power 9 will be common. Okay, don't worry, I will do it. So see, actually it will waste our time. If you are able to follow, then I will bypass few things. Otherwise, I will keep on explaining the things. So should I do it? So 1 multiplied by this, please try to imagine. 1 multiplied by this will be only this thing. Yes, 1 multiplied by something is this only. So r is 9. Why I will put r to be 9? Because we want coefficient of x power 9. So what will the coefficient? 9 plus 2c9, that means 11c9, or you can say 11c2. So I will get 11c2. Okay, so now here we have x power 18. So x power 18 when multiplied by this thing, what r should be given so that we get x power 9? That is not possible, because r is from minimum we can take 0. So already it is greater than 9. I will leave this term. And we have 3 into x power 6 into 1, that is nothing but 3 into x power 6 only. So minus 3 multiplied by x power 6 we have. So we want x power 9. So r should be 3. So 3 plus 2, that is 5. 5c3, or that is nothing but 5c2. 5c2. So I will get 5c2. And then x power 6 into x power 6, that is x power 12. Obviously x power 12 is more than 9, so I will leave that term. So finally this is my answer. So 11c2 minus 3 into 10. 5c2 is 10. 11c2 is what? 11c2 is 55. 55 minus 30, 25 is the answer. Don't worry, you may be thinking that it is very difficult and very big. No problem, I will make you fluent in it. Please try first, please take snapshot. Okay, then I will make you fluent in it. No problem. Slowly I will bypass the step, then you will get more clarity.
Okay.
Oh yes, so I will solve many questions. Okay, yes, so just to revise, we will do it fastly. Step see, we have upper constraint as well as lower constraint. First step is clear all the lower constraint. While clearing all the lower constraint, we will do, see this 1 1 1. So I will subtract 1 1 here. So we will get upper constraint. Finally, we have got 5 5 5. So generative function for each variable. So x power 0 to x power 5. Again x power 0 to x power 5, and so on. So finally we have solved it. 1 minus x power 6 upon 1 minus x, and so on. Same for everything. Then we will write generative function for the problem. Generative function for the problem will be multiply all these three by multiplying, and then we will apply this formula. Okay, 1 n minus 1 plus rcr x power r 1 upon x power n, 1 minus x power n. Okay, and then we will take n is equal to 3. Why we have taken n is equal to 3? Because at denominator we were having 1 minus x power 3. That's why we have taken n to be 3. So finally we have got it. So now we will try to find the coefficient of x power 9. Why x power 9? Because RHS was 9. That's why. Okay, yes. So finally we have got it. Now let me solve another question. You will get more clarity. Okay. Yes. So now slowly I will bypass the steps. Okay. So the next question is, yes. Next question is this: 5 red chocolates, 8 blue chocolates, 7 green chocolates, and we want to choose 10 chocolates. So what are the ways? So first of all, we will write the equation: number of red chocolates, number of blue chocolates, number of green chocolates, that should be equal to 10, such that xr is less than equal to 5, x blue is less than equal to 8, x green is less than equal to 7. So there is no lower constraint. Why? Because obviously minimum is 0 only. Minimum red chocolate you can take is 0 and so on. So there was lower constraint also. Why? Because it was outcome of dice. Dice outcome can be minimum 1, it cannot be minimum 0. But here obviously chocolate minimum is 0, that's why there is no lower constraint. We will directly apply the upper constraint. Okay, yes. So now I will write the generating functions. So this is less the x red is less than 5, less than 8, less than 7. So step number 2, generating function. So axr, generating function for red. So x power 0 plus x power 1 dot 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 x power 5, 1 minus x power 6 upon 1 minus x. Generating function for blue: x power 0, x power 1 till what? 8, x power 8, 1 minus x power 9 upon 1 minus x. So now I think you have got it. I will not apply formula again and again. I will count it 9 terms now. So 1 minus x power 9 upon 1 minus x. That's it. Okay. So the next is generating function for x green: x power 0, x power 1 up to x power 7, 1 minus x power 8 upon 1 minus x. So these we have written the generating function. So now I will write generating function for the problem. Step number 3, generating function for problem. This was for variables. So I will multiply them. So ax, that will be a of x red multiplied by a of x blue multiplied by a of x green. So 1 minus x power 6 multiplied by 1 minus x power 9 multiplied by 1 minus x power 8 divided by 1 minus x whole cube. I think you have got it. 1 minus x, 1 minus x, 1 minus x. So I have written 1 minus x whole cube. So step number 4, I will not write the formula again and again. I will simply write it. So n is 3 here. Okay. So I think I should not write the formula. You can see it now. N minus 1 plus RCR, x power r, 1 minus x power n. So n I have taken 3. Again 3. Why? Because 3 variables. So number of variable, that is 3. So I will apply 3. So what I will say? Step number 4, 1 minus x power 6 multiplied by 1 minus x power 9 multiplied by 1 minus x power 8 multiplied by sigma r is equal to 0 to infinity, and n is what? 3 here. So 3 minus 1 plus RCR x power r. And what we want to find? Coefficient of what? See this. RHS is 10. So from here I have to find the coefficient of step number 5. Coefficient of x power 10. So now I will apply some common sense. So what I will apply? I will simply say, when I will multiply, see, first I will multiply these two. What I will get? 1 minus x power 9 minus x power 6 plus x power 15, I will get it. So I will not write it. If you write it, you will solve it and you will simply waste the time, because I want coefficient of x power 10 and already I will get x power 15. It is not possible to get x power 10 from x power 15. Not at all possible. Why? Because r is 0. So minimum is 0. Negative I cannot take. So I will not write it. So I will simply write it like this. Multiplied by 1 minus x power 8. Okay. So now I will say 1 into 1, 1. 1 minus x power 8 minus x power 9 plus 9 plus 8. It is more than 10. Just leave it. Then minus x power 6. Then plus x power 6 into x power 8. Just leave it. It's not for us because it will be more than 10. So multiplied by sigma r is equal to 0 to infinity 3 minus 1. So that is nothing but 2. So r plus 2 CR. R plus 2C. R plus 2CR is nothing but R plus C2, R plus 2C2. I can write like this also. Just to save the time, I am doing all these things. I think you have got it, na? R plus 2CR
Yes.
or R plus 2C2. One and the same thing. Yes.
Mm.
Now I will simply do it. So for 1, I have to apply R to be 10. So I will simply say 12C2. That is the beauty. Now 8. I want 2 here. So 4C2. Why minus? Because here we have minus. Then again minus 9. So I want 1. So 3C2. Then 6. 6 plus 4 is 10. So 4. So 6C2. Solve and get the answer. Very simple.
So you
Is it
do
okay?
it with such a flow, and it seems to be simple for you. But we need a practice. So.
No problem. I will solve many questions. No need to worry. Please copy it. I will solve another question. You will get more clarity.
Okay.
Yes. Done it?
Yes, sir.
Okay. So now I will try to bypass the steps. Now please try to listen very carefully. I will bypass the thing. I will say, see, I want to pick 12 chocolates and 4 different kinds of chocolates are with me. I will not write equation. I will not do things. I will simply bypass the thing and I will say like this. I will say, just imagine 6 now. So see this. First step was to write the equation. I am not writing it just to save the time because already it is given to us. What was that in writing equation? Simply write it R blue green that is equal to 10 because we want to choose 10 chocolates, and then I was just copying all these things. Okay, so there is no good work which we are doing. There is no meaningful work. And then step number 2 also no meaningful work. See, for 5 I will simply say 1 minus x power 6. For 8 I will simply say 1 minus x power 9. For 7 I will simply say 1 minus x power 8. And here also no meaningful work. Now step number 3, generating function for the problem. I was simply multiplying them. So why I am doing these steps? I will simply write these steps. Okay, so 1 minus x power 6 into 1 minus x power 9 into 1 minus x power 8 upon 1 minus x cube. Why? Because there were four things. So directly I will imagine the generating function and I will multiply them. So I will do it here. So now what I will say, 1 minus x power 7 multiplied by 1 minus x power 9 multiplied by 1 minus x power 4 multiplied by 1 minus x power 6. Is it okay?
Yes.
Plus 1 plus 1 plus 1 divided by 1 minus x power 4. So I have directly written generative function for the you can say the problem.
Okay.
And now I will replace it. So now I will say 1 minus x power 7 multiplied by 1 minus x power 9 1 minus x power 4 1 minus x power 6 multiplied by sigma r is equal to 0 to infinity, and n is what now? N is 4. Please, you have to focus. So 4 minus 1 plus RCR or x power r. So now for what I have to solve? 12 chocolates I want. So I have to solve it. So find the coefficient of x power 12 from here. X power 12 I have to find coefficient of x power 12 from here. So now no need to do lengthy steps and all, simply solve it and get the answer. Okay, so now what I will say, so I will multiply them first. So what will be our answer? 1 minus x power 9 minus x power 7. Just leave it because it will be more than 12. Now solve it. 1 minus x power 6 minus x power 4 plus x power 10 I have to write. Okay, yes. So now I will multiply them. So 1 minus x power 6 minus x power 4 plus x power 10 because it was multiplied by 1. Then minus x power 9 plus, I will leave it, 9 plus 6 15, leave it, 9 plus 4 13, leave it, 9 plus 10 19, leave it. Now I will get minus x power 7, then plus 7 plus 6 13, leave it, 7 plus 4 11, I have to keep it, and then 17, leave it, multiplied by sigma r is equal to 0 to infinity. So r plus 3c r x power r. I think you have got it. R plus 3c3, r plus 3c3 x power r. Yes, so now I will simply solve it. I will put the value 12. So 15C3 minus 6, so it will be 9C3, then minus 4, so 8, so 11C3 plus 10, to 2, so it will be 5C3, then minus 3, so 6C3, then minus 7, and here 2, so 7 plus 5, 12, so it will be 8C3, and then plus 1, so 4C3. Solve and get the answer.
Yes, sir. Yes,
Now
sir.
now I think
Yes,
it's
sir.
easy now.
It gave us. Yes, sir.
Hmm. Yes, take snapshot. I will jump to the next slide.
Okay, sir.
Done.
Yes, sir.
Okay, so next is 8 red chocolates, 6 green chocolates, and 5 blue chocolates. We have to select 11 chocolates. Now I will simply write the equation. Please let me know if you are comfortable or not. 1 minus x power 9, 1 minus x power 7, 1 minus x power 6 divided by 1 minus x ka cube. And now I will not write that also. Divided by 1 minus x ka cube, I will bypass that also. R is equal to 0 to infinity. N is what, 3 here, because 3, so 3 plus 1 and n minus 1 plus rcr, n minus 1, n minus 1 plus rcr, okay, x power r. Okay, and now I will find coefficient of x power 11 from this equation and get the answer. Let me do it, no problem. Let me do it. So I will so coefficient of x power 11 we want to find. So 1, then minus x power 7 minus x power 9. I will leave that because it will be more than 11. Multiplied by 1 minus x power 6. So 1 minus x power 6 minus x power 7 plus it will be more than 11, leave it. So minus x power 9 plus it will be more than 11, leave it, into sigma r is equal to 0 to infinity, so it will be r plus 2 c2 x power r. So now I want 11, so for 1 I have to put 11, so it will be 13c2 minus, then we are having x power 6 na, yeah, so 5, so 7c2 minus 4 plus 6c2 and then minus 4c2. Okay, yes, so solve and get the answer. So I have told you in GATE exam 1 or 2 step question, so this is clearly 2 step question, only 2 steps. Okay, yes, so that's it. So here we have overt permutation and combinations. Okay, so let me take snapshot.
Yes, sir.
So finally, permutation and combination is over. All the 6 categories are over. Permutation with no repetition, limited repetition, unlimited repetition already over. Combination with no limitation, limited repetition, and unlimited repetition. Everything is over. So next 7th category is distribution problem. We will start that in the next class.
Yes, sir. Out of 9.
Yeah, out of 9, we have done 6 categories, and then 7th category we will start in the next class.
Yes, sir.
Okay, so okay then. Good night. Bye bye.
Good night, sir. Thank you, sir.
Okay.